Hello, everyone, and welcome to this free webinar within the organization of Team CAD and PAS. My name is Marco, and I will be the host for today's session. Team CAD is a well-known company that provides Autodesk solutions for many years. In partnership with colleagues from PAS, you will get the essential information about PAS and Revit collaboration. On this occasion, we choose to call it the Mighty Duo. For a Q&A, we have a spare time and after the last speaker. I will now welcome our speakers, Mr. Leonid Kornstein, Vice President of R&D and Global Market PAS, Mr. Nick Maximenko, Vice President of CAD PAS, Mr. Alex Pronin, Chief Specialist, CAD Department PAS. Enjoy. Mr. Leonid.
Okay, thank you so much. Welcome to the webinar. Добро дошли на наш webinar. So first of all, I will show you some review presentation about what is PAS, what is PAS solutions. And then we will show you live some integration between Revit and our software. Let me share the screen. Just a moment. Okay, do you see my screen?
Yes, Leonid.
Okay. Okay. So PAS software suite is a suite for piping and equipment analysis, simulation and sizing. And currently it contains of four main software programs plus some utilities. These software programs are PAS Hydro System for piping fluid flow and heat exchange analysis and sizing. PAS Start Pro for piping stress analysis. PAS Equip for different kind of equipment stress analysis such as pressure vessels, columns, tanks, and heat exchangers. And also nozzle FEM for nozzle shell junction stress and flexibility analysis, and also some other non-standard piping and equipment elements. So this software is widely used, and our market segments are process plant, piping, and utility, first of all, but we also have a significant presence in district heating, transfer piping and equipment networks, and we're also used in oil and gas gathering, distribution, storage industry, mechanical and in-house piping, and of course by manufacturers of pressure vessels and heat exchangers, columns, and other process equipment. So we position ourselves as tools for every piping and equipment engineering design. So we're trying combine power functionality of our software with a very effective user interface and integration with popular 3D tools to reduce analysis time, effort, and cost. And we also have some kind of embedded intelligence, both by algorithms, libraries, detailed health system, training system, videos, and so on, which makes our software very easy to implement, to start to use just in days. So this is some kind of our geography, originally from Russia and Soviet Union for many years. We now already a worldwide company with lots of users all over the world. So now some words about parts of our PAS suite suit. First about PAS hydro system. This is how it looks. And it's more than 40 years of development, more than 600 users worldwide. And this is an ideal tool for day-to-day use on different stage of project, from process engineering, from principal design to detailed design. It can calculate steady state flow of any of piping of any complexity for real liquids, gas liquids mixtures, gas liquids mixtures like oil, gas, and water, and even liquid solid mixtures, so named slurry flow. And also it can make a search analysis of transient liquid flow. I have water hammer analysis. Of course, for this analysis, we need powerful thermodynamical engine, and we have it. We have our own libraries with more than 1,000 and half different substances, and can calculate the mixtures, the physical properties, and thermal equilibrium. And we have very good water and steam library. We have GERC library for natural gas, including liquidized natural gas. And we have also integration with some other thermodynamical package like French similar thermodynamics or PVTC. We can calculate two-phase flow using different models, including Tulsa University fluid model, and we can define flow patterns like bubble flow, slug flow, and so on, and show them, and which part of pipeline have which flow pattern, which parameters, and so on. For the model, we can multiple representation. We can do in 3D, in full 3D, scaled, non-scaled, on the plan, in ID-like, and so on. This is some examples from our customers. And of course, the results can be seen both in tables and can be seen on the model, color-coded. You can see everything. You can see how waves are transferring along the pipeline, traveling along the pipeline in Waterhammer. Some examples from our users. Here is an example from Caspian Pipeline Consortium. This is a tank farm.
Yeah.
And this is from Aalborg project for solar power project in Dubai. So we have a lot of different interesting projects. Now about PAS StartProp, one of our most famous software, with again with a long history and very widely used, more than 10,000 license of 3,000 active users worldwide, and for language supported lots of different national and international stress codes, and you can see how complex point we can analyze. Okay, we can show results with all the formations and color-coded and where the stress concentrations are, and with all. And we can calculate all types of different piping, including above ground and burying on steel construction, vacuum, cryogenic, high pressure, high temperature, and not only metal, but also non-metallic piping, plastic piping, and FRP and GRP piping. And here is the list of current codes we support for stress analysis. To include all international codes, ASME, EN, British code, Chinese code, Russian code. Also some codes for equipment, for different loads, wind, snow, ice, seismic loads, database of standard details, pumping elements, and pumping steels. And we also support some uh, standards for possible loads for different kind of equipment or nozzles of equipment. And here is a database for standard materials and elements. And we can analyze the thermoplastic piping analysis. All the material data is already included in the database, and it's very easy also to edit if necessary. And we have a very advanced engine for Buret piping analysis, taking into account all kind of interaction with the soil. And we can define steel structures inside the program and analyze the behavior of pipeline interacting steel structures. And also we can do seismic analysis. It includes seismic wave propagation for Buret piping. And we have built-in finite element analysis engine using our PAS nozzle FEM software. It's fully integrated with PAS StartProf. And so if you have some nozzle or some non-started elements, you just by press of the button, you can run nozzle FEM in the background and get all necessary flexibilities, loads, and so on. And we also have interaction and integration with hydro system. So we can calculate, get model from past StartProf. We can make necessary calculation of water hammers or define parameters of slag flow and define balance loads and export the balance loads back to start and using them on the phase of analysis. Post-pass StartProf, we also have this verification and validation manual, very detailed, and which is delivered to any user. And here we checked on multiple examples that the calculation is correct. We compare them with manual calculations when possible, with calculation by Caesar2. And by the way, we found a lot of Bex in Caesar 2. And this is how reports are looking like. We can export them with all details on MS Word to be included in your project. And we also can export it in the form of 3D stress ISOs, both for start and for hydro system, with all drawings and also analysis results. Again, to check and to include into your project documentation. And some analysis, some examples from our users. This is a big oil gas project, crude compressor station. And here the power station pipelines from China. And here are some examples from district heating network analysis. In China, for example, they have a large diameter, very long, very complex district heating networks, and we can do it easily, and they use it. Okay, and some words about two other parts of our suite. PAS equip stress analysis of pressure vessels. Here are the different types of equipment which can be analyzed, and including some complex equipment like double heat exchangers or with piping. And results are very detailed for each element. You can see all equations, all forces, moments, and so on. And we also have 3D solid kernel, and this allows us to export our models to IGS, STEP, ACES, Parasolid, and some other popular formats, and to import them in the CAD software, for example, to AutoCAD or to SolidWorks or to any new software which supports this formats. Some examples. Here is the vessels from our customers, a real vessel and models. And last but not least, PAS nozzle FEM. This is our FA engine, which developed just to make this kind of analysis for complex geometries like nozzle cell connection, but just by the click of the button. So you just need to define your geometry and so what type of shell you have, what type of nozzle connection you have. And the software will do all other tasks itself. So it will create appropriate mesh, it will make analysis, it will process the results and show it in post-processor and get all allowable loads, got flexibilities, and you can use these flexibilities in other software. And here is how we can integrate all our programs together, but I already talked about this. And here is, for example, some of our integrations with other software. So PassStarProf is integrated with a lot of different 3D pad software. It can import and export Isogen PCF files, and in this way it can interact with almost all 3D plant design systems. It can import and export files from our competitors like Caesar2. It can interact with AutoCAD, and it can interact with Autodesk Revit. That, by the way, this arrow now is two ways. That's, Nick and Alex will show you. And a similar diagram is for PAS hydro system. And my last slide is about specifically Revit integration models in the PAS. So we have several Revit integration models, and we will show you today two of them. This is Revit PAS StarProf integration and Revit PAS Hydro System integration. So Revit PAS StarProf integration is now two-way integration. So you can not only import the models from to PAS StarProf from Revit model, but also return some results and some changed to Revit PAS. And we can also import it to PAS Hydro System. And interesting separate model, which I would like to mention, is our Revit PCF model, because Revit and in piping modeling opportunities, they don't have PCF file production for Isogen. So we just fill this void and create our own models, and we have some users who efficiently use it, for example, to forward these configurations to some other CAD software specifically for piping design, to produce isometric, for example. Okay, this is what I would like to show you. And now when you have some general impression about our software, let's show you how we can integrate it with Revit. Nick?
Yes, hello everybody. Thank you for joining us webinar. My name is Nick Maximenko. In our team, I'm responsible for all integration development between our software and third-party software. Mr. Alex Pronin will help me to show live the workflow of integration between Revit and our software, PAS Start Prof and PAS Hydra system. So when you make a design of the process units, you always have a task to transfer model and attributive data from one system to another. So let's see how can it be possible with our integration solutions. So on your screen, you can see the module interface. It's very simple and it performs two main functions. The first is export piping system from Revit to PAS Start Prof format for stress analysis. The second one is import support load data from PAS Start Prof back into Revit and update the support's position if they were moved. The data is imported via open file format. It's internal PAS Start Prof format. And let's see how it can be done. So to perform the export, the elements in the Revit model in the piping system must meet the following requirements. First of all, they must belong to the special categories. So they are highlighted in the project tree. So the categories is pipe or pipe fittings or pipe accessories. And the next requirement is the element families must contain a number of specific set of parameters. For example, like this and like this. So let's briefly take a closer look at the parameters. So let's make a closer look to this elbow. The parameters can be divided into two groups. First group is mandatory parameters, which define the geometry of the element, and they are mandatory for export. It's like outer diameter, radius, etc., etc., etc. The next group is additional parameters. They can be stored in the Revit model. Mostly they are such as like a process parameters, various options of transmitted elements needed for analysis, like corrosion allowance, weld stress factor, and something like this. How you can operate with these parameters? You can add parameters to the family from the standard Revit function shared parameters file. It is supplied with our module, like this. The list of required parameters for each element you can find in the user manual in these tables. So the user decides how much data should be stored in Revit BIM model. And also you can use the mapping file between Revit and PAS Start Prof. As you see, it's a classic JSON file. It can be manually configured for a specific company needs. So working with this file is also described in detail in our user manual. So let's go back to the module and transfer our model from Revit to PAS Start Prof. So you just need to add a pipeline to the list, define the file name, and click export. So the export completed. Now we can go to PAS Start Prof, select our file from the first step, and just load it into PAS Start Prof. So we need to define some data like codes. Okay. Let's switch to isometric view. So as you see, the model the same. So since we filled in the minimum required parameters in Revit model, we can immediately run the analysis without entering any additional data. So we just need to save the file, just click OK, and run analysis. So here the analysis results. Here is the deformed shape of our pipe. So let's make some changes to this model. For example, we want to add two sliding supports in the vertical branches here and here, and move supports in the direction of the T, in these directions. So let's make this change. It's very easy. We just need to add the node element, define the position, like this. Okay. And we need to add the node here. Okay. Now we can insert sliding supports. Okay. And then we will move the guide supports. Okay, here. And here. Now we run analysis again. See that there are no red cells in the alerts window. And now we can transfer this model back into Revit. So let's see the deformed shape, everything okay with the model. So during the export back, we need to create two files. First file will contain the geometrical data, and the second file will contain the analysis results. So, okay. By the way, it's not necessary to load in Revit both files. You can either update only geometry or only import loads. But now we will select two files and see what happens. So pay attention to the position of the supports. So they were moved in the Revit model, and the special markers were added on the vertical pipes. This is the placement of supports. So this back functionality export does not require any additional user configuration. So you can see the forces were also transferred. So the all attributive data were transferred to this model. Okay, let's see another interface. It's the interface between Autodesk Revit and PAS Hydro system. It's look like mostly the same like previous interface. We just need to select the pipe, just add it to the browser window, define the file name, and just click export. So the export was completed. Now we will transfer this file to Leonid. Leonid, please go ahead. Can you show us what you can do with this result of the export?
Yes, sure. Let me share my screen. Okay, here. Sorry. Oops. Just a moment. Okay. Now you can see Hydro system window, and let us import this file. Oops. Okay. We need XML file. Here is the XML file. Oops. Okay. Here is our model. We can do look at it at 3D, real 3D. So as you can see, it's identical, and not only identical, it have all geometric configurations, lengths, and elbows, and valves, and it split it and describe it in the terms of branches. And you see that we also have inner diameter and outer diameter. So it's almost ready for some hydraulic calculations, but not all data is here. You need to define, first you need to define fluid transporting along this pipeline, and for this you go here, for this part. And here you can define different thermodynamic libraries, or you can define fluid properties simply by inputting them. But let's select, for example, water stream. Then you don't need to add even any composition. And of course, we need to define some boundary conditions. We need to define some pressures in the source or in the end nodes, or we need to define preliminary flow rates. Okay, I already did it to save the time, and here this prepared example. Okay, here is the same example, but yes, but I defined some, if we can show this, just a moment. Oops. Just, oops. Calculation, look, oops. Uh-huh. Data, yes. Oops. Mhm. Yes, you see, we can see all components, we can see branch, and you see that in branch I define source pressure in the source, and I also define some flow rates which we would like to transfer. So we will do some check of this system. We will calculate all pressure drops, calculate what will be the pressures at all points of the system. Okay, let's calculate the thermal flow. Okay, here it is. We have all the results. We can look at them in general on each range, which is the starting, which is the maximum velocity, which is start pressure, end pressure, and we can see each element. We can see velocities, densities, all components of pressure drops, and so on. And we also can see it visually. We can see where is the maximum pressure drops. We can see velocities. Here is the maximum velocity, the rate, and so on. Okay, let's do something more interesting. We'll open the same file prepared for water hammer analysis. What I made here, I define that this valve is closing, yeah, after one with in 1 second and after some 1 second interval. And let us see what will happen. And I also defined here 2 points to look for changing of parameters, one near the source of O4 and one just before the closing valve. Let us see, and let us see also just meanwhile. So first we need to do steady state flow, okay, for isothermal flow, for example, okay, it's right. Then on the basis of the thermal flow, we will calculate this Wertheimer. Okay, let's look at the pressures. Okay. Just see the calculation. Oh, sorry, running here. Yes. Maybe not so, not very convenient. Let's switch to this here. Can you see it? No, no, it's not seen here. But let's look. And okay, calculation is finished. And let's look at some plots. Let's look at pressures. Okay. Okay. So you see what's happening here when it's closing. So we have a peak. We have a really big pressure peak before the closing valve. This is what we could expect because of this Wertheimer. How we could change it? Well, the simplest way is just to close this valve more slowly. Oh, let's close it in 5 seconds and recalculate this. Okay. We can stop this calculation at any moment, but I'm trying to do what I don't see. No, I don't see it. Okay. Now let's look at pressures again. Oops. As you can see, now these peaks are quite smaller. But this is, of course, the simplest way to manage Wertheimer effects. But there are a lot of others. We can put some dampers. And of course, the natural way is to calculate unbalanced forces because of Wertheimer. Unbalanced forces is a forces which act to elbows, to teeth, and so on. And here is a tool. We can do force export, can calculate unbalanced forces for Wertheimer and can send it to Cesar2 to StatProf in a special format like this one. Name, StatProf Wertheimer, save. And then we can open it in StatProf and it will apply it as additional forces in our StatProf analysis. And the same can be done with two-phase flow. Here is a slug flow calculation to StatProf. I also add some insulation material here. You see that we have a standard insulation material database, and you can select some different insulation. For example, some minerals. Let us select, for example, rock wool blanket. Okay. And we can define temperature, define high temperature, 90 degrees. And I would like to analyze, to make not isothermic, but heat and hydraulic analysis. Okay. Yes, the results are here. We can look here, we can look, for example, very cool. Look at this. Where is our heat losses? And we can see how the temperature change. It change very small. The change are very small because of good insulation. So I think it's enough for today, and let us give some time for questions.
Okay, so if you have any questions to the participants, to our speakers, please you can ask them, or I will put in a chat an email address where you can send an email with a specific question. Thank you all for joining us and be a part of this webinar, and I wish you all have a nice day.